All right, so today's talk for the next hour or so is called the Pragmatic Approach to Web Components. And so just a little bit about myself. My name is Jacob Huser. I'm a principal web developer at LinkedIn. I've been with the company for about, I guess, half the company's life and have seen us move from YUI to jQuery, seen us try and pick up new technologies, all while trying not to break the legacy code that we've put into the site to get it to where it was. So it's just a little bit about me, but today there's some stuff we're going to talk about, and before we get there, here's some of the things we're not going to talk about. So there will be no W3C spec sing-alongs. I promise I won't do a soapbox rant about the WebKit prefixes and how we use them, and I'm pretty sure there will be no dancing. Yeah, I'm sure some people will appreciate that. Instead, the stuff we're going to be talking about is the what and why of web components. What are they? Why do they matter? How do we use them? And we're going to actually look at some live code. So as part of the preparation for this presentation, we have live code that's going to be in Polymer, Ember, Angular, and React, all providing web component-like functionality. We're going to be doing a really basic carousel just to show the code, just to show some of the differences, and more importantly, to show that we can actually do web component-like functionality today. And then finally, we're going to talk a little bit about responsible component usage, how we're going to do web components in a responsible manner, how we're not going to mess up the internet in the process, hopefully, and some of the lessons we can learn from our predecessors who had similar design patterns before we actually came along with web components. The way I like to do these presentations is when people have questions, just put your hand up. I'll repeat them as we go. I'd prefer if people wait till the approximate end of a slide or the beginning of a slide, just because then we can talk while it's doing weird transitional stuff. But also, instead of getting a bunch of questions at the end, I find it's much better we have the conversation as we go, as we explore this topic together. So hands go up, I'll call on you, I'll repeat the questions for the recording and also for the room. I've only got one of my two lapel mics, so if I end up taking this down, hopefully, can people still hear me in the back okay? Ish? Really well? Yeah. Okay. For Carl's sake, I'll use the microphone. Helps me stay old school. So let's actually dive in. What are web components and why do we care? So let's go back in time to the start of the web, where aside from the doc type tag, things were pretty simple. You had your HTML tag, you had a body tag, you had some content, and things were pretty straightforward. You used paragraphs for paragraphs, heading tags for headings. Things were really, really simple. Pages were easy. The idea of a single page app didn't exist, and you could go through, submit forms, perform tasks. It was pretty easy. So what happened? Well, what happened was we decided to start adding UI elements to the page that weren't natively supported by the browser. These were things such as tabs. These were things such as dialogues, date pickers, and stylable drop-down lists. I realize to this day we still can't style the select element. The thing is that with every one of these things, they came with opinion about markup, about CSS, about JavaScript, and you had to add these to your page. You had to add these layers of complexity. And the web got fat. For those that are not able to see the slide, it's a picture of a kind of chubby looking beluga whale. So he's kind of looking around wondering what happened, and what happened was the web to him. So here's a screenshot of LinkedIn's page, something I'm not particularly proud of, but it highlights the problem. Our homepage has I'd say about 11 layers of nesting until you get to the first content item on the page. And that's just the profile image in the top left corner. We've got divs, we've got spans, we've got non-semantic classes, we've got script tags as placeholders where you can see the stuff that says like LinkedIn/control. We've got a minimal number of IDs, but more than I'd really care to have throughout the page. And all of this is to create a rich page. If you crack open Gmail, it actually has approximately 47 layers of nested divs in order to provide the content and functionality. That's the web we've created. We've taken a pile of trash and made something that looks good if you look at it in just the right light. This is a photo, actually. This art installation is actually a pile of trash with the right light. The artist actually collected 6 months of trash, piled it just so, and when shined with a light, actually creates the shadow in the background of two individuals who are leaning back to back, kind of enjoying life. But this is the web. This is what our websites look like right now, is people see the stuff on the wall, the pretty shadows, but we know inside, we know what we used to make it. And that's not good. That's not the web we want. We want a simpler web. We want something that goes back to basics, where we're not piling in div tags, piling in spans, basically piling in all the trash. When you use something like Twitter's type ahead, shouldn't you be able to just refer to it by a tag, say twttr-type ahead, and specify a source? How many people here have actually looked at the site to-do MVC? Just a quick show of hands. Okay, about half. So to-do MVC is this website that has JavaScript examples of pretty much every framework that you could possibly think of, and has examples of building a to-do list application using all these different frameworks. And it's great, but for every one of those, there's piles of CSS, piles of JavaScript. Why is it your to-do application can't be a series of tags, can't be a local storage tag, a to-do app tag, and in there there's to-do items, really semantic tags? And if you want multiple to-do lists on the page, why can't you reduce it down to a single tag like to-do-list? And that encapsulates all of your stuff. The return to semantic tags marks the start of the extendable web. What you saw in those last examples with Twitter, with the to-do list, that's the part of web components that people really understand and grasp. The idea of taking functionality and reducing it back down to its semantic tags, being able to extend existing tags to add new functionality. It turns out HTML is a great thing. With HTML tags, we already gain a lot of benefits. HTML tags are semantic. You can encapsulate things. You can put forms inside of a field group and show their association. You can configure them. You can put for attributes on labels to indicate the text inputs that they go to. And they're already DOM friendly. We already know how to get elements by ID, call document query selector. If we could express all of our rich interactivity in tags, then we can use the existing JavaScript APIs to manipulate them, duplicate them, clone them, configure them, do whatever we want. And that's the heart of web components. Web components contain several different specifications put together by this group called the W3C. I promise we won't do that spec sing-along I was talking about earlier. Trying to sing to a spec is just never a good idea. But web components themselves, besides having a fancy logo, really allows us to capture the heart and soul of this idea of having tags that represent a lot of content. The co-creator of the web components spec, Dmitry Glazkov, said, "Custom elements is a bedrock API. We should be able to create any tag that's in the browser using custom elements." That's how strongly he believes in it. Web components consist of several different pieces. There's a shadow DOM, which means you can have an entirely custom document embedded within a tag. There's scoping rules, and there's import rules. But at the end of the day, most people are going to remember web components for web components equals custom HTML tag. And because we're using an HTML tag, we're going to get all this stuff for free. Eventually. So it turns out I'm kind of picking on Internet Explorer here, but they're not alone. Native web component specifications are only available in 2 of the 5 major browsers. Chrome is kind of the gold standard right now for web components. Firefox is close behind. They have one minor bug they're working on fixing. Opera is using the Blink engine, so they're just a little bit behind in terms of the actual implementation, but they'll catch up to Chrome relatively quickly. I'm unfortunate to report that Safari is actually on the does not support native web components list. Some of the work that had been there in Shadow DOM was pulled out because the code wasn't being actively used, which is good code hygiene. And they're working on bringing it back, but it's not there yet. And as of IE 11, nobody actually knows what Microsoft is doing. Hopefully they're implementing it. They have them listed on their site as specifications under consideration. So hopefully we'll see them in a later version of IE 11 or IE 12. Unfortunately, that means that 60% of the market share is tied up right now in things that don't support web components. And if we want to use native web components, we're going to be waiting for a while. The good news is we don't have to wait if we want the benefits of web components today. It turns out that there's actually several modern web components here, and we'll actually go over them. I call these guys the Fab Four because I'd say about 4 years ago, all of them were just inklings in everybody's eyes. They didn't even exist. How many people here have actually played with, and I'll go through these frameworks one at a time, have played with Polymer by the Google group? All right. Angular. It's come up like 3 or 4 times, a lot of Angular hands. Facebook's React, a couple hands, and Ember, Ember.js. Cool. So one of the things that's worth saying up front here is, as we talk about the code, this is going to be an opinion-free section. We're going to be talking objectively about how we do web components. I don't really have a preference for what the best framework is for doing this. I'll leave the arguing to the questions section at the end of the presentation. Just know that you can actually achieve web component-like functionality with all 4 of these. So this is our target markup. We're going to be putting together a very simple carousel thing here. We've got a myCarousel tag. It's got 3 myCarousel items inside of it. And so we're going to kind of initialize this carousel with 3 things. The reason we kept it this simple was it gave us target markup that we could aim for. This would be valid native web components in a web component world. And that allows us to actually do our implementation in a very consistent manner across all 4 of these frameworks, so we can talk about the differences and where these different frameworks shine. So we're going to start with Ember. And the reason we're going to start with Ember is its carousel markup is currently the most non-web component looking item out of the bunch. Part of that is because Ember uses handlebars as its templating engine. And from there, eventually they're going to go to HTML bars. But they do everything inside of these script tags and they compile their templates. I've actually highlighted line 2 here, so this is the one people can see, where we use a handlebars helper called e-carousel to kind of indicate where the Ember carousel object is. And then we put the content nodes inside of it. So when you do web components in Ember, you get the benefit of being able to go back all the way to IE 6. Not that anyone should be using IE 6 by this point, but you could go back there if you really, really needed to. Eric Brin did a bunch of work to make sure that the Ember stuff works. It's slower the older the IE you use, but it actually is functional. As I mentioned, there's a handlebar helper for e-carousel. That's the handlebar syntax with the double curly brace there, that instantiates the component. And then there's a matching template with a handlebar's name of components/e-carousel that stamps out our template. There's a special handlebar helper called yield, which captures those original nodes, so all 3 of those carousel items, so you can do something with them. And then the JS convention in Ember, you can map e-carousel to app.eCarousel component. Ember does a lot of convention-based magic, and as long as you follow their naming conventions, things auto-instantiate for you and off you go. So this is the actual carousel implementation, and assuming the internet is working, we'll actually get a JS bin here at the end, where we've got a content tag here with our yield helper, just to highlight some of the big things, and then inside of Ember to select the carousel items, we can do var $items equals this $, carousel e-content items. And that can give us our original initialized tags. We can go feed those into the carousel models inside of Ember, and the end result is our carousel. So I'll animate this once so everyone can see, but for the most part, these things click, they wrap around. It's a very, very straightforward carousel. And all of these examples are actually going to be visible on JSBin. They're also in the presentation with the link at the end here, so everyone can go look at the examples, play around, clone the JSBin, try new things, just enough to get everyone going. So kind of moving from the really, really not native web components to the slightly less native web components is React. I know a lot of people haven't really played with React, so let's talk a little bit about the markup. So the markup looks something like this. This actually looks very close to our web component specification with r-carousel and r-carousel item. So a little bit of full disclosure. In this example, we're using a plugin on top of React called Reactive Elements. And I'll talk a little bit about that as well. If you were using pure React, you could do React top to bottom in your application and you'd be fine. If you want to have web components, and independent of whether or not you're using React, you want to just put this tag somewhere on the page and have it work, then you want to add reactive elements. Reactive elements with either the Mozilla or Google Polymer or Xtags shim will let you knock out custom elements, and you can register a React component and map it to your custom HTML tag. The good news is, because React uses a language called JSX and has its own compiler, it'll go all the way back to IE7. If you're using reactive elements, the polyfills go back to IE9. So you have the option of using pure React if you need to reach all the way back to older browsers. The other thing is that the JSX, the syntax that Facebook uses in JSX allows you to scope your styles and scope your script, your content script down into these local React components. So you don't end up with any seepage. If you want to refer to an element and say all A tags in this scope are red, it'll make them red. It won't leak out into the main page. That actually ends up being really, really powerful because now you've got that encapsulation piece. So whereas with Ember, we don't really have the full encapsulation, because with JSX we're compiling, we're able to achieve that encapsulation piece. So the implementation, either in a standalone file or in an inline script tag, is you put this JSX react.dom at the top that tells the compiler, hey, I'm React, I know what to do with this. We go in, we set up our items, and then we have, thanks to reactive elements, under the this.props, there's an underscore content, which refers to our content nodes that came from React. We can then call document.registerReact, and that associates r-carousel with this React component. Pull it all together, and there we go. We've got our same carousel. We've got the r-carousel you can kind of see here on the left. And then I've just got the JSX stuff inlined beneath it so that it kind of fits on one screen. And that's how you can get a React component going. Angular is probably the thing most people here are familiar with just looking at the show of hands. Angular is a little bit closer because Angular allows us to natively refer to stuff using the Angular directive syntax, and I'll get into that very briefly here. So we have ang-carousel with an ang-component, and then we've got our carousel items inside. When we do web components in AngularJS, our Internet Explorer compatibility is actually dependent on which version of Angular we're using. So starting with Angular 1.3 is going to be IE9 and newer. So just so people can keep that in mind. If you need IE8 support, you can use 1.2. Angular doesn't support IE7. I talked a little bit about this concept of directives. Directives are Angular's way of being able to specify or identify code to run within your markup. We're going a step further, and I'll show you in the code. We're actually going to declare a directive within the application that takes care of the ang-carousel object, just as if it were a fully custom element. And then the other important thing is that there's an automatic variable in Angular that you can request in your controller called $transclude. Through a whole bunch of Angular magic, you can put these $ variables in your function call. Angular will identify them, and it will give you back the proper objects. Transclusion is a property that's unique to Angular. It's their way of getting a copy of the original nodes before you go blow them away with your template. So when we go to implement in Angular, we still have to stamp out a template. So there's a custom tagline around ang-template and with for ang carousel. And this gives us our Angular template. We can then refer to it, and we can pull it in by saying document query selector, give me that template. We use angular.module and angular.directive in order to create the ang carousel. There's a little bit of convention in Angular where if you do ang-carousel, it'll automatically look for something with a matching camel case. So lowercase a and g, capital C carousel, it just maps that for you automatically. And then finally, inside of our directive, we identify the Angular controller. And you can see there we've got the $transclude. And the $transclude function gets as a parameter the original nodes. So this lets you get at those carousel items, populate the carousel, and actually build the output. We click over to the JS bin, and once again, we actually have a working carousel. And so when you guys are clicking through these slides, you'll actually be able to, for all these examples, they're all live JS bins, and you can actually see them actively working. You can play around with them, kind of do whatever you want. We've got a little bit of CSS in here where needed, just so people can see like ang template. We gave it a display none so the templates don't show. Let's see, put that back the way it was. There we go. And then finally, in the list of the 4 frameworks that we're talking about here in the first half of the presentation is Polymer. Polymer is built by the Google team, and its carousel markup is very, very close to web components. The reason for this is Polymer is trying to be a web components shim for all browsers. So we can actually expect what we're going to see is the closest to web components. Unfortunately, because it's trying to provide the shimming, certain functionality is not available except in what they call evergreen browsers. So Safari is evergreen because of WebKit, Chrome is evergreen, Firefox is evergreen, IE 10 and newer is evergreen, and that's Polymer's target. So if you want to get on board with the newest, latest, greatest, Polymer actually is probably the I don't support anything from the past-ish of them. So, and the way it works is you define a Polymer element inside of HTML. You say Polymer-element, you give it a name, and you say no script, that's just their convention, and it defines a custom element. Because Polymer is trying to shim web components, all of your JavaScript and all of your CSS is automatically scoped within the bounds of the Polymer element tag. So nothing leaks out. You don't have like changing a p tag changes all the p tags on the page. You get that encapsulation. And as a result, your implementation starts to look a lot like the implementation from the web component specification. You have a Polymer element. In this case, we declare it as p carousel. We then have a content ID that says, I want to retrieve content from the previous DOM, so the DOM before I instantiated. I'd say, in this case, I wanted to select p carousel items from within there. Then I can go in with Polymer inside of the script tag and say, this.content.getDistributedNodes. The getDistributedNodes function is a part of the shadow DOM, and that's part of what Polymer is exposing, is this new functionality. So you can say, give me the original stuff. Anytime you append child now, you're going to be appending to a fake node. And we'll see if I can actually pull that up here in a moment. The implementation is very, very straightforward, except I didn't put a background, so it's not as visible here. But like all the others, it clicks through. And if you come down here, you'll actually see here's our Polymer element with the template fully stamped out. And this is actually using the web components template specification, the web components custom tag specification, the web components shadow DOM. That's actually why I'm doing the presentation in Chrome, is because I know it'll work in Chrome, whereas with other browsers, it's questionable. You can do it in Firefox with Polymer. I could actually switch this over to native web components, and we could actually go all the way back to our original example, and we could implement that. So all four of these frameworks unlock the ability to do web component-like functionality. It's a different way of doing the web. No longer do you have to go in and say, okay, I'm going to have my JavaScript over here, and I'm going to have my CSS over here, and I'm going to have my markup in this third place all the way over here, and then I'm going to tie them all together. What web components gives us is that encapsulation. It's almost like having a bunch of iframes on your page, only without all the overhead of iframes. So how many people here remember the iGoogle webpage? A couple people, yeah. So the iGoogle webpage had all these concepts of widgets that you could put on your page, you could mix and match them, they were all relatively square-shaped. Custom elements really give you the ability to do something conceptually like iGoogle, but without any of the overhead. You don't have the iframes, everything is in the DOM, everything is running native JavaScript, and there's no trickery at that point. And that's actually the heart and soul of the composable web. We're going to be able to create all kinds of beasts with this, and it's going to be amazing. We're going to be able to create tags for everything we could possibly imagine. So the other big thing is that you can actually put them together. You can take, say, oh, I don't know, your web components that you do in Angular, and you can drop them into Polymer, or drop them into Ember, or drop them into React, and you can put them all together. You've got one of the co-creators of Ember saying that Ember templates should be able to work in things like Polymer. Before anyone says it, I realize there's some caveats to this. There's probably quite a big problem with putting frameworks inside of frameworks inside of frameworks. The end result of that is going to be that we're going to be taking this beast, and if we're not careful, it's going to end up something a little more like this. Aww, yeah. Which really kind of brings us to the last third of the presentation here about building a better web and being responsible with our web components. So the first thing, I don't even have a slide for it, so I'm actually going to talk about this very specifically here while I've got everyone staring at a really boring segue slide. We don't want to replace UI elements of the browser. So I'm making this as a request to all of you. Please do not implement X button, X select, X scroll bar, X, I don't know, someone else name a native browser thing. Oh, come on, browser UI thing. Which one? Which one? Yeah? List, there you go, X list. Don't do that, especially the ones you interact with. So much work has been done by browser vendors to make these things accessible, to make them work in a reliable manner. There's a really great post by Nicholas Zakis from about, I guess, 2 years ago, where he said, we can't implement a button. He talked about the evolution of the button tag, how as people needed to style it, we went from a button tag to a link. And of course, for those that are accessibility minded, you said, well, links are a terrible idea. You should actually make sure that it has more functionality. So we would add an ARIA role to it, and it would be a role button. And then we'd be like, oh, but you need to make sure you can tab to it properly. So we put a tab index on it. And we're still not to a button. The reality is we can't make a button like the browser can, that interacts the way the browser can. When we think about the UI elements we make, we need to understand that we want to build on top of existing UI components provided by the browser, not replace them. So with that said, let's talk a little bit about an old friend who doesn't even exist in terms of Macromedia and probably won't exist in terms of Adobe probably within the next few years. So I know we've been saying that for like 3 years, that Flash is going away. It'll go away, I swear. But there's a lot of lessons that come from Macromedia Flash. And the reason is because Flash has been here. The exact same stuff we're talking about right now, Flash has been here. It has components via the movie clips. It allows nesting of movie clips or components so you can do this whole don't repeat yourself philosophy that encapsulation gives you. It uses ECMAScript, the same foundational scripting language that JavaScript is built on. This is nothing new. We've actually been here, and we were here 8, 9, 10 years ago with ActionScript 2, the idea of movie clip libraries, and it was like, I think there was something like freeflashclips.com or something like that. We've been here. We've seen how Flash can get plagued by bloat because you have huge component hierarchies. We've seen the complexity when you're trying to trace something and you'll double click on your movie clip and that'll take you to your movie clip that you double click on, 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 that you double click on. Oh, there's a movie clip for the background color. Somebody decided to take a 1x1 square of blue and turn it into a background clip and put that in the select box, in the component, in the component, in the component, in the component, in the component. We can end up there if we're not careful. Thankfully, we have a few new tricks in terms of development, and we're not restricted to only the Adobe IDE in order to do it, and that's actually really beneficial for us. The first tool that's going to save us is going to be Bower. NPM could technically fill this role as well, but I want to talk specifically about Bower because of the way it resolves dependencies. In NPM, when you resolve dependencies and you say B depends on A, it'll put a copy of B inside of A. This works great for node modules where you want to have isolation, but it's terrible for the browser where you want to minimize the amount of stuff you download. Bower uses a system called a flat repository. And so inside of your Bower components directory, if B depends on A, you get a copy of B and you get a copy of A, both in that top level directory. And it's up to the build tooling to resolve those dependencies for you. That means that if somebody wants, if you end up with a framework and you want 8 different versions of jQuery, instead of having 8 copies of jQuery, you're going to be forced to normalize down to 1, and that'll keep the bloat down significantly. But something has to figure out the relationship between those build tools. The good news is Grunt and Gulp, both which have really kind of come into prominence within the last year, year and a half, have given us the ability to solve this. There's Bower plugins in Grunt. There's Bower plugins in Gulp. If you're over in Ember, Broccoli is going to have a Bower plugin soon. There's Fez, there's Brunch, there's, I don't know, you could probably throw a stone and like hit 7 different NPM browser management utilities. The good news is that these are catching up quickly. These are allowing us to resolve Bower dependencies and be able to make intelligent build decisions as we put our apps together. And unlike where you only had the limit of Adobe's IDE, we're dealing in just text. There's Atom from GitHub, there's Sublime Text, there's TextMate, there's Vim, there's Emacs. There's going to be a plethora of things that are going to make it possible for us to do our development and be able to do it in a really good manner. This is an exciting thing because that means if you want to go down and step through components and step through dependencies, all of our editors that we use as web developers are going to be available to us, and they're going to understand web components because they're going to understand JSON, and your Bower dependencies are in JSON, and you're going to be able to follow your web component chain, and it's not going to be this mysterious black box. So that pretty much brings us to the conclusion where we've got web components. We've got this really rich, available ecosystem at our disposal, and we can do it today. We can do it in various degrees today. If you need to go all the way back to IE6, IE7, you can. If you want to use cutting-edge browsers, you can. If you want to use native web components, you can-ish, as long as you're also not dealing with IE and Safari. But other than that, we actually have the ability to do great things. We have the ability to create new, rich interactions and encapsulate them in a custom tag. That's just something we've never really been able to conceptualize before. And that's web components, and that's what makes everything really powerful in this next web. So actually, we're at about 10 minutes-ish until time-ish, give or take, and I wanted to make sure there were questions. We can go back to any of the examples. All the slides are going to be online at philosity.com, which is my personal website, /OWC6. Is actually this exact slide deck, only I'm running it off a localhost copy. And yeah, so I'm more than happy to go back, walk through some of the examples, a little bit of history. Learning 3 of these 4 frameworks happened as part of building this presentation, and just to give people an idea of how powerful this has become. All those examples went from knowing nothing to having a working example in about 5 to 6 hours of effort. That's how good the documentation is. That's how good these frameworks are. That's how possible this really is. Yeah, so the question was, what are the downsides to web components? And I think a lot of the downsides we're going to see are going to be really similar to those we saw with Flash. It's going to be mismanagement and bloat. I expect when web components come out, there's going to be somebody that creates, I don't know, webcomponentsforyou.com, and you're going to be able to upload all of your web components for sharing, and they're going to proliferate everywhere. And that means, like jQuery plugins of yore, we're going to have to use a very careful eye when we look at web components to understand what are they doing, are they valuable, and are they giving us what we want. There's jQuery plugins everywhere, and for people that have worked with jQuery and have worked with plugins, probably have the experience of plugins are very hit and miss. Sometimes it's a fantastic plugin, sometimes it's a really atrocious plugin. And you have to go through like 8 or 9 different jQuery plugins till you find the right one. I expect we'll have similar problems with web components. I think that the other problem that we're going to see is a proliferation of components that strip away accessibility. So when I talked a little bit on the segue slide about the idea of buttons and selects all having all of this natural browser interaction that makes life easier, someone's going to create xselect. It's not going to be anyone in this room, because I told you all not to. But someone's going to do it. And it's probably not, you're not going to be able to tab into it right, or you're not going to be able to use the arrow keys just right, and it's not going to be accessible. And we're going to screw it up. It's going to go all over the internet. Hopefully these like 50, 60 people will help manage it and make sure that it doesn't go into their code. But at the very least, I mean, it's going to happen. And I think that's actually the biggest problem, is people are going to look at it like jQuery plugins and be like, these things are everywhere, they're varying quality. Hopefully most people will do the responsible thing and say, you know, our app has unique needs. We're going to build our own internal set of web components on top of a web component library, something that gives us a local storage module, something that gives us a very basic data model, things like that. Over here on the left? Yeah, so the question was, what's the difference between what we're doing with web components and what we were doing with XML? I think the biggest difference between them that we're looking at right now is we are effectively doing XML. I mean, ostensibly, we are, aside from adding C data tags everywhere, we're creating custom tags and giving them meaning, much like XML enabled us to. Unlike XML, we're not relying on server-side transformations such as XSLT in order to turn XML into markup. With web components, we're relying on the browser's native engines to do this transformation for us, to say, hey, this one tag represents actually this entire module of code. So that's probably the biggest definition. I imagine that somebody will create a web component XLT fancy thing, because we seem to be creating a lot of that stuff right now and throwing it up in like NPM. So somebody will create a transformation tool, most likely, where you can go from XML through XSLT into web components. I do know that there's already like gulp WC and grunt WC, which can actually assemble your web component object for you. So things are moving really quickly. Here over on the left, and then we'll come all the way back to the right. So the question was, what's holding web components back at the heart of it? And I think what's holding web components back is whether or not companies are able to identify the blocks of reusable components. It's a very different way. Just a year ago, we were talking about single-page apps, and okay, we're going to have models and views and controllers. That was all very, I think the term we tend to use is we call it an imperative web, where we use code to describe everything. Web components come to something that's called a declarative web. where you actually are using very strongly typed HTML tags to describe functionality. I think what holds the people back is that's a very different way of thinking. How many people remember trying to dive into Angular? I saw about half of the room that had put their hands up. How many people understood Angular on the first try? And there's 0 hands. Angular was a very different way of thinking. It was one of the first frameworks that really embraced declarative style. Everything's a tag. Well, what about if it's not a tag? Shut up, it's a tag. Like that was how it worked. And you had to rethink, like, well, where do I put my routing logic as in a tag? Where do I put my tag? What a tag? Tag. Like that was Angular. That's web components too. And I think what holds us back is that idea of thinking about things as reusable blocks of content and how they relate in a hierarchical structure so that we can embrace HTML. I think there will be pattern sites that come out. I actually do know there is one, I don't remember the URL for it, that has web components. If you really, which one? Components.kitchen, is that the one you're talking about? I think so, Components Kitchen, and there's another one which I should have put in the presentation. I'll probably update the slides today as well to make reference of it. How many people have used like the Google APIs before, like the JavaScript APIs? So your world's solved. There's actually a suite of HTML tags for web components that do everything. You want a Google map? Less than Google map, greater than. Oh, you want it with latitude and longitude? Less than Google map, lat equals, long equals, greater than. For docs, for spreadsheets, for Google+, for Google Maps, for all the Google stuff has web components already. That's how much they're betting on it. And from an implementation standpoint, you don't actually want to have a bunch of JavaScript that configures it and sets it up and then manipulates it. You really want to be able to just, here's my Google Map object, and then now I can access that with like document get element by ID and do whatever operations I need to on it. So I think it'll come with time. I think to your question again, what holds us back? We're being held back by a way of thinking more than the actual ideas themselves. Over here on the right? Yeah, I've actually, so the question was whether or not I've built anything more complex than a 3-item carousel that wraps. Yes. When you get into that, I didn't want to go too much into it because I wanted to focus on the web components piece. But every framework has their own concepts around message passing and encapsulation strategies. So Ember, because you're working in the Ember app component namespace, you can actually use standard eventing in Ember in order to have components talk to views. Components are really just an extension of Ember views for those that want to get really technical. And so they can push things back into models, which can be listened to by controllers and can push data back into other views. And you can take advantage of Ember's data binding. React has its own message passing system where using JSX, you can add on-click handlers and you can bubble things in and out. Let's see here. Angular has its message passing system, which I started down that road and then I realized I was running out of time. So I decided I should really probably finish the Polymer example. And Polymer, because it's standard, is trying to polyfill, you can just use regular events. And so it's really going to come down to style. If you're using web components, you can just attach them to your page and you can partially adopt a framework. Ember and React also let you go whole hog, so does Angular. Polymer is about the only one that technically doesn't because, I mean, you can make a page of web components and you can have a my-app tag at the top, but fundamentally, like, it's a slightly different way of thinking. So depending on how many or how few web components you want, they all have systems for the messaging, for inter-component communication. Some of them, like Ember, have gone a step further and have already thought through Ajax, data binding, React has thought about DOM updates to minimize reflows. So they've all kind of got their strengths. And so in terms of things I've personally played with, I've done a lot of Ember, I've done a very little bit of Angular, and I've done a lot of Polymer just to see what the specification is supposed to behave like. Cool. We've got about 5 minutes until time for any other questions if anybody has anything. Yeah, in the back and then over here on the right. So the question was, how are people unit testing their Polymer components? And I actually think there's going to be 2 problems that people are going to run into. The first problem people are going to run into is dependency injection. So your Polymer element or your custom element, once we get native, depends on this other thing. How do you make sure you're dealing with only your custom layer in the composition? How are you testing just your stuff without a weird dependency on the underlying infrastructure? And the piece to that, I think, is that we don't have an answer yet. AMD, which is a popular module system for the browser, it stands for Asynchronous Module Definition, a bunch of great work done by James Burke and the Require.js folks. Kind of touches on this where we deal with dependency injection, and there's some stuff out there like Redefine, Squire, which allow you to kind of mock your dependencies. I think we're going to need something like that for web components. I don't think we have an answer yet, and I think that's one of those pieces that will really hurt our ability to do component level testing. Because in theory, it's integration testing, not unit testing at that point. But trying to test how that piece works together and then works in an ecosystem is going to be a big challenge. So I don't think we have an answer yet. Yes, I am an employee at LinkedIn.
Can you tell us, and stuff that's already on the web, which of these approaches are currently used?
So currently at LinkedIn, we actually have a older homegrown framework. That was some of those script tags when I showed everybody the large, like really horrible nested markup stuff. We're currently running internal prototypes where we're using LI backbone for some stuff. We have an internal backbone build that we use just to avoid having to like rewrite a bunch of commons code between apps. And we're actually doing a lot of experimentation with Ember. Part of our requirements, as I talked about with the Internet Explorer boundaries per framework, IE is a big dictator for us about what we have to support. While we've been able to retire IE7, we're still working on trying to nudge people off of IE8. Until which point we do that, we have to look at frameworks that make sure they support IE8 and try and plan for it in advance. So that's actually how it kind of informs our decision. We do, like many other tech companies, we do like hack days and stuff once a month where people will just build whatever they want, scratch itches, things like that. And so I've seen people pump out different React items, different Polymer items. So it's getting used in like prototypes and stuff. But internally, the stuff we've been actually focused on has been primarily, if you were to pick any of these component strategies, it's been Ember. And that's just because of the support matrix.
Great, thanks.
Cool. All right, so we're at time. It's about 10 minutes till. Give people time to go out, shuffle rooms.